Hello, we're back. I realized that part 2 of this video was not legible, so we are doing it again. All right, so I think the last time we spoke, it was me answering question BI. Percent of cups that dispensed that contains greater than 10.8 ounces. And so I said that 10.8 corresponded to one standard deviation. Anything greater than that had to be to the right, because greater goes up to the right as opposed to down to the left. So I also then went through and talked about how we could figure out what that represented as a percentage or a proportion. I said that we knew that it was to the right of the median, and that median always represents 50%. I said that it was to the right of the standard deviation of one standard deviation, so it was outside of this piece between my finger and my pencil. So it was outside of this second half, the top half of 68, so I needed to take half of 68 to get 34, and then I subtracted that 34%, which we don't want, from the half of 50 to give me 16%, which is the total I said there. Okay, so then B double I was the percent of cups dispensed that contains between 9.6 and 10.2 ounces. Between 9.6 to 10.2. Okay, so 9.6 and 10.2 are exactly on a standard deviation of the mean and the negative standard deviation. So we have to have this value here. Okay, and that is half of going from negative standard deviation to positive standard deviation. So that's half of 68, which is 34. Okay, so each of those are 34, right? Because 34 plus 34 gives you 68. So that's equal to 34%. Okay, so that piece there was B double I. B double I. All right, okay. Okay, so it said percent of cups dispensed that contains less than 9 ounces. Okay, so anything that's less than has to go to the right of the number. 9 ounces is here, so we're going to mark it on the diagram, and less than has to go to the left, right? So it's everything to the left of 9.0 ounces. Now, it is exactly on the -2 standard deviations, which is mirrored by the +2 standard deviations, and we know that -2 to +2 represents the 95%, right? Because we wrote that there. Maybe I better star that. Okay, so if it's outside of the 95%, but it's only half of this side, not the other side, right? So we want half of 100 minus 95. Okay, so we want half of 100 minus 95, which is equal to 5% divided by 2, which is equal to 2.5%, represents less than 9 ounces. Okay, so then C says, is there a significant risk of a 12-ounce cup overflowing? Okay, so where's 12 ounces? 12 ounces is way over here. Well, we know, based on our rule, that a 3 standard deviations is including 99.7% of the population. Okay, so from here to here, we've got 99.7% of the population. Is there a risk of that cup overflowing? No, because anything that's outside of that is the difference between 100 minus 99.7. There's so the difference is 0.3%, represents 12 ounces or more, and 8.4 ounces or less. Okay, that's a super small amount. So therefore, there's no risk or no significant risk. Overflowing. Because it represents half of 0.3%, which is equal to 0.3% divided by 2, which is 0.15%. So that's less than one person in 100. Okay, so to make that manageable, if we said that was less than 1%, 1 in 100 people wouldn't even be affected. Okay, you'd have to so if that's 0.15% is equal to 0.15 out of 100 people, right? That's the same as multiplying that by two groups of zeros. So that's 100 times 100. That would move the decimal. So 15 over. So only 15 out of 10,000. That's negligible. Or so that 15% or 0.15% represents 15 people out of 10,000 people, or 1.5 people out of 1,000 people. That's highly unlikely. So there's no significant risk.